Okay, I think we have a probably good enough crowd to get started. So, thanks everyone who joined. There are some awesome talks happen in parallel. So, again, thanks everyone who decided to come and hear me speak. I'm not sure that was the reason why most people are here. Probably some of you were too full to actually walk to another building, but thanks anyway. So this talk is kind of my process of becoming a better data scientist, and it starts with about like 2.5 years ago when I moved to the Bay Area. I was living in Israel at the time, and I moved to LinkedIn, which back then was like the mecca of data science, and I started kind of getting myself familiar with the tooling there. And one thing I realized that most of the LinkedIn data science team actually uses Pig for developing its code. And for you, those of you who never saw Pig, you can think about it as kind of a scripting language created out of that looks awfully like SQL. So you have select statements, you have filter statements, and you have group by statements. So if you take SQL and break it down to like individual statements, that is kind of what the Pig looks like. And in my company prior to LinkedIn, I was the company called LivePerson, which is definitely a much smaller company, and we were actually using Scalding, which is this wonderful Scala wrapper in order to write MapReduce jobs. And I was trying to convince people to kind of migrate that. I tried to Pig, I hated it from like possibly day 2, and I realized that hey, let's try to, instead of kind of making myself work like the other 70 data scientists at the company, let's have the other 70 data scientists try to work more like me, which is definitely a great idea for anyone who joins a new company. I would highly encourage that. And I was having this conversation, but unfortunately, I wasn't getting much traction. I was trying to explain all the benefits that Scala has to, and they were just not buying it, getting it, or I was just doing a bad job. And then I realized that actually my approach of kind of putting one tool against the other was actually not correct one. What we were kind of had a different opinion on is just around our way of thinking. And this is where kind of I want to start my talk. But let's start with a kind of beforehand I will just say that and that talk was kind of referenced here a lot. One of the best talks I've ever seen is the one by Rich Hickey, which is kind of simple made easy. And so this talk will be similar to that, though it won't be about a specific technology or a specific tool. It won't be similar in the sense that his talk was actually great. And well, we'll see how close can I get there. So that's, again, what you should guys expect from it. So one of the questions I ask a lot is, people come to me and say, hey Vitaly, you're this thought leader, you're this amazing data scientist. It doesn't happen, but since I'm get recorded, maybe, people will pick up on that. And they tell me, hey, what should I use, Hadoop or Spark? Spark is the new shiny thing, it's like so much faster. Hadoop is like everything has to be in this like map, shuffle, sort, reduce paradigm. And Spark gives me so much more flexibility. But on the other hand, some people say, hey, Spark is just Hadoop with caching. It doesn't scale, it doesn't, it's still buggy, it doesn't provide a lot of things that I actually need to do on top of Spark. Which one should I go with? And my answer is handbells. I'll try to explain myself, but it will take me a while. And this, I wanted to share a story with you that I recently heard on NPR about, well, this handbell world. And I hope by the end of the story you will kind of understand what I'm kind of aiming at. But if not, you will know much more about handbells. I promise you that. So it started with a company called Schulmerich, which is based in Bucks County, Pennsylvania, and that was the largest manufacturer, I think, in the world of these handbells. You know, it's this kind of nice thing that people, kind of church choirs play in Christmas songs. It's like, you know, you hold it in one hand, and it's either, you know, one person holds two bells, and you know, they just need a very good coordination between the people to like ring their bells at the exactly the right time, or you know, people can use multiple bells. But I think probably, you know, if you're over 8 years old, then you've probably seen it at least once in your life. So the story begins with a gentleman called Jake Malta, who was the chief engineer at Schulmerich designing these bells. Which, this is like the first thing that hit to me is say, hey, you know, it's a bell, you know, there's something that hits something and there's a sound. Why do you need a chief engineer? But apparently you do. And so Jacob Malta, somewhere in the 70s, decided to leave Schulmerich, and he said he wanted to go on the quest to create the perfect handbell. And he went to Europe, he studied with other European bell manufacturers. He kind of educated himself about the physics of sound and acoustics and bells. And eventually that led to him opening a new company called Malmark that he founded that created a new handbell. What's fascinating about this entire, and between these two companies, I think today they control like 90% of the market of handbells. They both are based on the same exact location. This is actually where they are today, their headquarters. But when Jacob Malta just started, he was actually right across well, his former Schulmerich company started. So you probably are wondering, hey, you know, what was so great about this new bell that he created? And I just would like to apologize here. I actually had a sound where it's comparing the two bells in it, but for some reason it did not work. But the point is actually they sound pretty, when the two bells of the same note ring together, they sound almost exactly the same. So it's important to kind of where I'm going to story. But, you know, since we're all very technical people, what's interesting about, I guess, in the story is not just about handbells, but about what's the difference between these two handbells. You can see on the left we have the Schulmerich bell, and on the right we have the Malmark bell. And while they, you know, I just ask you to spot the differences, there are many kind of differences, there are many different pieces in this handbell, but the most important, the novelty of Jacob Malta in creating the new Malmark bell, you can see there is a rod going through the bell, and there is a hole like in the top section of the bell where this rod comes from. And by removing that part, it's actually a part that in the normal bell casting process were left, because this is kind of the part that the machine was holding onto while casting the bell. By removing that part, Jacob Malmark believed that he created the superior handbell. And now, you know, once you develop your technology, you need to market it. So Malmark started basically competing with Schulmerich on, you know, who gets to buy these bells. And I also, not only I want to kind of play you the sound, which is very unfortunate that I can't, I also want to bring the bells. But anyway, when I found out, it's actually a single bell costs, you know, anywhere between hundreds of dollars to thousands. So you can imagine how much it costs for an entire orchestra to have these bells. It's probably, you know, in the range of the tens of thousands of dollars. So it was, you know, a huge business. There's not so many potential customers that are using the square bell, so it was important for Jacob Malta to somehow showcase that his bells are superior to the his previous company, Schulmerich bell. So they kind of, you know, started with this marketing campaign that this thing became ugly, and it was like 30 years of legal battles. Malmark said, you know, something along the line, our sound is more pure, right? Or Schulmerich then responded, where our handle is not hollow. which is, for most of us engineers are not very, precise statement. While of course the R handle is not hollow, this is kind of factual. It really doesn't tell us a great thing about. It doesn't tell us a lot about, hey, which bell is actually better for my goal of using it in my orchestra. So they decided, because Jacob Malta was an engineer, he said, hey, how can we find a more scientific way actually to test, something that people cannot dispute? It was both on, of course, the Schulmerich people also kind of went on that quest. And actually Schulmerich, the one that devised this mechanism, which I couldn't find a best picture. So this is a bass pedal, but you can kind of imagine from it. It's something that hits a certain element with exactly the same force every time. And Schulmerich then, found their, killer blow, their silver bullet, and they finally came out. Our bell is actually louder. It's 1 or 2% louder, so, and of course we as humans cannot reproduce this, the same exact force. So actually, if you would ask any human being, say, hey, do you actually feel the difference in the loudness of these bells? The answer would probably be no. But still, they found their what they thought would be the silver bullet. It's a very long story. It ends actually recently by Jacob Malta passing away, his counterpart in Schulmerich passing away. Their new management, they actually said, hey, let's stop fighting, and now they're, I guess, everything is well. But the more interesting question is how does it relate, to the topic of conversation today? And also, we're, some of you saying, hey, Vitaly, but we're not like that. This whole thing is, these are nothing like the claims we make about our tools. We're much better than that. And I'm saying you're probably right, but there is probably another, other audio conference that is going on where they say, hey, no, these things are actually important, the 1% or 2%, it's actually what we do and it's our daily work. And we need to select the best tool. And by the way, up until this day today, there's only a single choir that actually uses a combination of both bells, and they're very, very passionate about their company. They either Schulmerich people or they're Malmark people, and also when they select musicians for their orchestras, they want you to be in line with their way of thinking. If you're a Schulmerich person auditioning for a Malmark choir, you might not get the job. So I guess the point is to make a long story, and it is a long story, short, but I just, when I heard it recently on NPR, I said, oh my God, it's exactly what's going on in a lot of the tech scene. Of course, none of the people in that room, it's other people I'm talking about. Arguing which is the marginally better tool is not a great use of time. I'm saying, Spark or Hadoop in that sense, there will be a lot of talks talking probably in this conference about how great is Spark. By the way, just I'm now director of data science at Salesforce, and we use Spark. And just to kind of not in any way you should interpret it as me bashing Spark. It's actually, I think it's a great tool, and that is the tool we use on my team. But I'm saying, even if we again use the analogy of the handbells in the choir, actually what the handbell, the choir does is exactly using this tool, and that is the output of that tool is what every one of their customers actually gets to experience. For us, for me as a data scientist, we create so many different things, from actually running the algorithms, the models, the user experience, and eventually the product that we put in front, that the back-end processing tool that we create is actually, no one gets to see it anyway. So, okay, so tools, or specifically, very, very similar tool is not important to me. So what is important for me as a data scientist? Well, the best way to answer that question is to start with another question, is what is data science? And this question we can actually even simplify it further, is ask what is science? Because honestly, data science is just, it's a wonderful creation that, gets people like me to stand in front of people, in front of the audience and, say how wonderful I am. But every single scientist, whether they have their, the title, the word data in their title or not, is actually using data in their day-to-day work. I just happen to be one that explicitly mentioned that. So what is science? Science is, generating, in a very, very simplified manner, is generating hypotheses and testing them and eventually coming with new conclusions. So one thing about science, at least I observe from my work, is that in terms of generating hypotheses, its quantity has a quality of its own. That is, if you are following Quora, that is the tagline for Yishan Wang, who is a very prolific member of Quora, and the former CEO of Reddit. And I agree. At least from my experience, the better data scientists are just the one that can go through more iteration and more ideas quicker. And here, after like 13 minutes of talking, I finally get to, I guess, a point where, hey, we're getting closer to the topic of this conference. So I put the slide, but hopefully, I'm preaching to the choir. I don't have to convince you that, if I'm using something that declarative, modular, correct, type, and all the wonderful things that functional programming has to offer, I can just get more things done. I can test more hypotheses in a day or in any time unit. And when I actually test more, eventually I get to better insights. Eventually we get to, better customer experience, better products, and everything's great. So I just, put the slides and hopefully, everyone will agree. So I guess the conclusion from here is everyone should learn function programming. That is the conclusion, at least I came from my experience as a data scientist, and that is what I guess what my disagreement with my colleagues has boiled down to is they were trying to do things in a way that I didn't think it was ideal. But the question is, so how do you learn functional programming? That is, I guess, in the crux of the things, at least I was then, after my realization, I said, hey, now that I realize what's a problem, let's figure out the solution. So one way to start is, learning Haskell and the craft of functional programming. Like, if you really want to be great at functional programming, you should definitely know Haskell. If you want to be a great functional data scientist, you should definitely know category theory. That is a must. Another thing that everyone, I think, should know is lambda calculus. It is very, very important to our day-to-day job. And here are just selected quotes that I like from, these books and other things on the topic. So a monad is just a monoid in the category of and the functors, and a Billing group is just a set. You can read it. And there is just three kind of reduction of lambda expression and this. Can you raise your hand in a room who actually understands all three? Alexei here. Awesome. Are you looking for a job, Alexei? Okay, so I hope you understood that I was joking because I have no idea what's written here, honestly. But this is the reply I got when people were actually, taking the steps, say, hey, Vitaly, you haven't convinced me, but you're so damn annoying that, I will try this thing you call functional programming. And, I gave them all this wonderful material about everything that is great about, functional programming, and this was the response. Well, this is the nice version of the response I got. And it got me thinking, okay, like, maybe they're right. Maybe, it's me against 70 people, and it's not that they don't care. It's not that they are bad at their job. It's not that they're, just don't want to, interact with me or listen to me? Is there really a problem there? And then I finally, got my closure and found my eureka moment. Here it is. Imperative data science. That is, I think, the future. And you might ask yourself, hey, Vitaly, you're crazy. Why are you coming to Scala Days to talk about imperative data science? Here's my answer. If I can make it here, I can make it anywhere. I really want you to be, the harshest you can be around the ideas I'm about to present, because if I can convince you guys, I really will convince anyone. So let's begin. The first application, which is the most basic fundamental data science, I call it Spreadsheets, which is, doing spreadsheets in an imperative way. This is how we know spreadsheets today. I still haven't, figured out the UX, so I'm borrowing from this Microsoft product. Hopefully it's the last time you'll see a Microsoft product here. I don't know if it's like a big no-no, but hey, they have a pretty good spreadsheet program. So you see I have numbers between 1 and 10, and then if I want to calculate the sum, I actually use the sum operator that this particular spreadsheet program has to offer. So you might ask yourself, hey Vitaly, it's like, it seems pretty simple. I'm saying it's not. It's like, it's probably a monad or something. Like it's, I don't know, I just don't feel comfortable with it, and this is probably what my colleagues. There's a better way to achieve the exact computation. Here it is. We set up a cell to be a 0, which is obvious because we all know all sum starts from 0. Everyone that took, any programming class from high school and forward, we know that, when we want to perform a sum over a collection, we initialize a variable to 0, which is something that by using sum, no one ever told us, but this is an important thing that, was just hidden from us. And then we have, a for loop, again, a very, very familiar structure that we're doing. We're iterating over all the things and, just adding whatever our index is, and of course, because we like to be statically typed, we indicate that I is an integer, and we adding I to the cell K1. I'm sure everyone can understand that simple mechanism, and again, I think this is the future. This is the way we can get more and more programmers to become data scientists. So let's talk about the advantages. It's very familiar. It's easy for machines to understand, which is something we do not get with functional programming. It doesn't hide any code. We don't have, this, any kind of weird abstraction that we don't know what's going on. It does not require complex algebra. Everyone knows what a plus is. Well, sum can be defined in multiple ways, and it's like we are going to this whole complex algebra thing, and it's fast as hell because imperative is fast as hell. I don't need to, convince you about that. Okay, I think I haven't sold you on the idea yet. Let's try the second application. IQL, imperative query language. We probably all use in our day-to-day job SQL, but there are problems with SQL, and this is actually one of the problems I think Scala is experiencing, and a lot of people complain about Scala. There are multiple ways to do everything in Scala, and the truth is there are multiple ways to do everything in SQL as well. We can have these constructs that probably, it's the old way of doing SQL. If we want, the total income of a certain employee, we are doing this again, sum from employees where whatever, but there is not only declarative things in SQL. We also have cursors that we can use in SQL. And cursor, actually, you can achieve anything you can do with a SQL statement, you can do with a cursor as well, but the opposite is not true. So the question is, if we now have to narrow it down to a single way of doing things in order to keep things simple, which one should we go with? And the answer is maybe, we can present the same functional dilemma in a functional way. If I would tell you that, in the collection library, I will force you to keep only map or flat map, which one would you keep? Flat map, of course, because flat map can do whatever map does. The opposite is not correct. So this is the way that you do things with cursor, which is exactly achieve the same goal, however, in a single way. We initialize, there's still some SQL here. I'm still, it's declarative, it's ugly, I know, I'm working my way through it. But we define a cursor, we initialize again a variable to 0, we go with a for loop, we iterate over, we add to the total val, we return this total val that will have the right answer that we correct. And let's talk about the advantages of my imperative query language. It's a single way to do something. It's easy for machines to understand, does not hide any code, does not require complex algebra again, and probably it's fast as hell. Okay, I feel you need another one. Let's do it. Big data. This one will be a bit long. Well, because big data, and it takes a lot of time to go through it. But let's try to see how we do it. And there is no big data, presentation that can happen without someone counting some words. So this is what we will do, because obviously I would like to fulfill my data scientist duties. This is one of the ways that we would do word counting in any of the kind of Scala-like, whether it's Scooby, Scrunch, Scalding, or anything you can come up with. We can all read the code, we read from somewhere, we flat map, we group by, and we map values. It's ugly. It has a monad, no one can read it. Because, people just can't read monads. And once you know a flat map is actually a part of a monad, for most people, they just stop understanding the code once they realize that. So let's look at a better way to do that that will be more intuitive for the majority of people. This is the start. So we have a class, which is important because we understand class map that extends a mapper, which is it's object oriented, which is it's a goal by itself to have your code object oriented. So now that we extend, we have the next line. We have iterable that will kind of, for you that are not familiar with word count, you can see we will use that one statement in the last line that we'll write once, because every time we see a word, we will output this word with a 1. But we'll wrap it within an iterable, because obviously we all know how hard it is to serialize the number 1. We still, humanity still hasn't solved that question about how to serialize integers. Word is just a text, and then we go, we read every line that we get from our now overridden map function that gets several arguments that I'm sure they're all very, very important, because otherwise they wouldn't be here. We're throwing in exceptions, again, important. And now we're using a tokenizer, because again, we have to use tokenizer string, because if we're really passionate about enterprise coding, we should have a wrapper class around everything. And while our tokenizer has more tokens, we set our word to tokenizer.nextToken. Everything makes perfect sense. That is the way we actually all grew up rationalizing about how to achieve certain goals. And then we write this word, and the one we created at the beginning of our class, and something just happened, which is, I'm sorry about that. And let's close it. Where's my deck? Yes, okay. No, but obviously that is only one part. I will go through the other part a little bit more quickly. We have the reduce that extends the reducer. Everything is the same, and then we see the exact same structure that we're now seeing in every one of my imperative application. It is, we initialize our sum to 0, we iterate over all the values, and we increase the sum. which is values.next.get. That get is needed because it's an int-writable, and we output a new int-writable, which is the sum, and now we have a word count. Of course, I kind of cheated here a little bit. There are about 200 more lines of very important setup that we need to do to have our computers actually understand fully. We need to be very patient with how we talk to computers and make sure they understand every single thing they want to do. But that kind of, I think it conveys the gist of what I'm trying to convey here as the way of doing big data processing in the new and the right way. So the advantages of iBig data. It's still functional, which we can say, hey, it's functional for all of you, functional programming aficionados. Hey, I have a function called map, I have a function called reduce. Stop bugging me, it is functional. But in a good way, right? It is object-oriented, which I already mentioned. It's a goal by itself. Everything should strive to be object-oriented. And it gives you full control over the execution about, what is a map stage, what is a reduce stage, everything we can control. I really, really, really hope that you got that the last part was not a joke, and I wish it was. But it was not. This is for all of you that did not get kind of my point here. This is the actual way you write map word count. Again, with additional 200 lines of code, but this is the way you write functional big data programming. So after sharing these 3 examples that I was working when I was trying to create my new imperative data science manifesto, I came to this conclusion. Yeah, maybe imperative is not the way to go around data science. Maybe functional is actually better. But the question is, can we make it simple, right? Can we make it without this crazy books and the quotes I shared with you earlier? And my point is, it's already kind of is, because if you look at this statement, which is list 1 to 5.sum, is that different than the way we use Excel? Is the fact that we have the word list there, is what keeps all these computer science PhDs I work with saying, oh my god, I'm using Java, this is like just so complicated. Or if I took my previous SQL query and just kind of wrote it this way, is the fact that I use filter instead of where, or map instead of select, and let's say the internal function is slightly I write it in a slightly different way, is that the problem? I don't think so. I think we just are not doing a great job in setting people up for success around functional programming. It's actually fairly simple. It's just the question is what are our analogies? If our analogies is monoids, then it might be harder to understand than if we say, hey, this is the same thing you had in Excel. And in order for us to go beyond Excel as SQL, because hey, yes, everyone can understand Excel SQL, but how can we maybe take it to the next level? So I'll go with a very kind of crash course to introduction to functional data analysis, or as I like to call it, basic math. And I will just introduce a very simple library that is, it's not a very simple library, but it's a great library, but I will introduce that very simple concept of that library. And this library is called Algebraid, and one of the nice things about Algebraid, the creator of Algebraid and Scalding, he actually said that if you think about Scalding in a kind of more deeper way, Scalding is just a way, once we use, the right functional programming and category theory constructs, it is just a way to run basic algebra in MapReduce or on Hadoop. And I would like to kind of just, again, give you a very crash course on it. These are 5 apples. This is one way to count how many apples we have. This is another way to count these apples. We actually can perform partial counts. Can anyone tell me why can we perform partial counts on the apples? Yeah, I think I heard it. So yes, because counting and summing is an associative function. But how does it help us? What, why do we even care about associativity? So again, I think someone said it here. It's because of parallelism. When something is associative, we can easily parallelize. We can easily break it into subtasks and actually just compute partial aggregation and then combine it all. And once we can do it, it's much faster. And this is what basically kind of taking basic category theory and running it on top of whatever, whether it's Spark or Hadoop or whatever your favorite tool is. Having associative functionality is way more important whether you run it on one or the other. So let's talk about, hey, what is this associative thing that I talk about? So here's the first construct of category theory, which is called semigroup, of type T, which has one operation that is plus, and plus, takes a left and right, and what it must ensure that it keeps the plus operation should keep the types within the same types. That is why it returns type T. And if the operation is associative, it's wonderful. And that is basically it. And in case no one ever heard the term semigroup, for some reason in Scala conferences, people understand it better when I say semigroup is a monoid without the zero element, which if you think about it, is kind of funny. But yes, so semigroup is a monoid without this zero element. So here's just one example with sum that we show. The integer plus operation is just the plus, as we all learned in elementary school. However, but that is, okay, what can you do with just a sum operation? Well, actually a lot. So just by using this one very simple construct, we can count, we can sum, we can perform min-max operation, we can do Boolean operation, string concatenation. We might not ever give it to it much thought, but the fact that pretty much any language support, when you use the plus on two lists, it concatenates these lists is because it actually makes sense. But there are more complex structure that we can say, hey, the plus operator has some meaningful sense into them, and moments like average, standard deviation, priority queues can be as well just represented as we take two priority queues, we sum them together to get a new priority queues. Bluefin, min hash, hyperlog logs, counting machine, and stochastic gradients are just few of the examples that we can do. And again, why is it important that we can represent this operation as monoids? The importance is once we did that, it becomes completely parallelizable. We can do a stochastic gradient descent basically in much faster way that does not require anything else, just by rethinking about, hey, how do we take two gradients and create a new gradient out of them? So this is kind of another meme of, okay, monoids. They really are everywhere. When my team and I do coding, and when I review their code, you cannot believe how many times they think about an operation that I just tell them, hey guys, think a little bit. That can be represented as a monoid, or more precisely as a semigroup. But okay, monoids, I guess you're convinced. We can do a lot of monoids, but what more than monoids? We have rings as well, which is, ring is again is a monoid with a product operation and other additional elements. It's not really important, but for me it's more important to understand, for you guys to understand the concept. Hey, what is a ring? Okay, we can understand the monoid, two lists. If we add them together, then we can get them. But how about products? So we can think about matrices, right? For you who don't remember basic linear algebra, the dot product of two matrices is basically we take the rows, we take a row, we take a column, we multiply every row element with the corresponding column element, and we then sum all these products. So the way we can think about any matrix multiplication as kind of a more, in a more general way, one of them, like I mentioned, is called a ring, but for not to use complicated terms, is let's call it matrix operation, and we basically have an element-wise operation, and we have a final reduction after we perform all the element-wise operation. This is the entire the trait that you will need to implement in order to support matrix multiplications in your code. So this is, of course, the support, the way we would do it for any numeric matrix. However, we can actually take this idea, if this is a general concept, why do we need a general concept if it has only a single instance, only a single implementation? We can think about matrices in more ways. Matrices are actually a very, very important construct in data science. Pretty much anything we do in both data science and I guess computer graphics is somehow boiled down to matrix operation. Matrix can be other things as well. Matrix can represent graphs, as we all, I guess, learn at some point in our career. And this is a matrix that represents this graph. And now my question is, what if I define the element-wise operation as the sum and the final reduction as taking all these partial sums and actually performing a minimum on them, and then took a matrix and multiply it by itself? Does anyone can guess what would be the result of that operation if I just redefine my ring, or like I called it here, the matrix sub, and just use it for a matrix multiplication? So I will give you the answer. It's actually, I will get the shortest path, which is kind of, the point here is, again, is not to say that this is how we should implement a shortest path algorithm using, representing our graphs as matrices, but it's more of a use case to show you that, hey, we can take, if we can think about that the plus operation that we know about numbers can be then generalized to lists and maps and other things, we can say not only plus operation, we can also think about product operation that can be generalized not only for matrices but also for graphs. Now, hey, a multiplication on two graphs suddenly makes some sense. So to sum it all up, I believe, and again, preaching to the choir, but I think, if we continue hammering on this message, other people will get it. Functional is intuitive. This is the way we think, at least in math. This is the way we grow. If you tell me, hey, Vitaly, a kid that's growing up, what is more intuitive to him, Excel or assembly? I think the answer is simple. Functional is simple in the rich Hickey sense. It's actually much simpler constructs. And functional is powerful. I only showed you two of the most basic constructs of at least category theory, and as you go with it, you can do a lot more. And one of the where you can actually see more real live examples of if you, let's say, if you really care about, say, hey, Vitaly, we buy it, the concept makes sense. Let's how do we see it in action? Well, I highly encourage you to go to Dean's talk tomorrow at 11:35, the unreasonable effectiveness of Scala for big data. It's really effective. Thank you. Do we have time for questions? So I guess if anyone has a question, maybe come up to the mic, so it will be recorded. If not,
So have you tried this presentation with your coworkers, and how did that go over?
So I tried it with my new coworkers yesterday. And what's nice about my new co-workers, they all report into me. So they actually do not have a choice. So one of the things I joined Salesforce is to kind of create their data science initiative. So we already hired and we keep hiring. So now they all report to me and said, I have a very kind of simple way of management. I tell my employees, I will really not force a lot of things on you, but Scala is definitely one of the things. So, if you don't like it, maybe that's not the place for you.
Hey, thanks for promoting my talk. I was wondering what we could do to make things better, to grease the skids a little bit.
To increase the skills?
Grease the skids, make things easier for people.
So one thing I said is I think the proper analogies. I think everyone gets Excel and SQL, and I think so when we kind of similar where I think the rest of the Scala community did a great job with kind of promoting Scala, at least at the beginning, as Java without the semicolons, right? So maybe we can have the Excel but without the, or SQL but with something else, and then understand, hey, you know what? If you're in your SQL statement doing sum and you understand the concept of sum on on integers, can you expand your mind a little bit on, hey, this sum can work on more? And once we say, hey, you know what, it works on lists, it works on maps as well, and we say, hey, so what is the general structure of it? And we realize that the general is just one single function, that is the plus operation, then everything just magically happens.
What do you think of the names we're giving to these functions? People are very familiar with select and where. They're not as familiar with filter and map. I've actually found those to be quite the obstacle to having someone easily understand what's going on. Why not use the same words that they're used to in Excel and in SQL?
So it's a great question, because it once, I think, like probably in my career the most flaming I got was for proposing that maybe, and maybe it answers your question as well, in implementing pig in Scalding. So just saying, hey, you know what, let's create a DSL where filter is named where, and map is named select, and have people to ease into that structure. Instead, if we can have, so kind of the idea behind creating a pig in Scala, which is a terrible idea, don't do it, but just I'm saying that the idea behind it is we say, hey, a lot of people waste a lot of time by using pig is on creating UDFs, user-defined functions, but now at least let's get them started with, hey, you're using the same exact pig, but write your user-defined functions in Scala instead of Python or Java or whatever they used to, and kind of get them easier to it, and then kind of transform them from pig to like the same Scalding construct. We'll say, hey, again in pig, instead for each generate, just let's call it map, then I think that will not be a huge problem. But I think if really, so honestly I think it's, the better way is the tough love, which is the one I implement today, but now because I can. But if you cannot, then yeah, maybe just coming up with an easier DSL that does not use the term flat map or God forbid a monad, that may be, just hey, select or map or select and filter will be better. Okay, I'm out of time, but thank you all again.